Let's say you see this kind of a simple question in your chemistry jam exam. How will you solve it? It is very simple. Let us solve it together. The question says, what is the IUPAC name of the compound below? This is very simple. Let us name this compound together. You can see that this compound is an alkane. Why is it an alkane? Because it only has single bonds. This compound is an alkane. Alkane. This is A. Why? Because it only has single bonds. It only has single bonds. So the first step to take in naming this compound is to find or to locate the longest continuous carbon chain. The longest, let's say the longest continuous carbon chain. We are locating the longest continuous carbon chain. That means the longest continuous carbon chain. So if we were to count like this, 1, 2, 3, 4, 5. This is 5. Let's try if we can have another way that will be the longest. If we count like this, 1, 2, 3, 4, 5, 6, 7. I think this is 7. We can also count like this, 1, 2, 3, 4, 5, 6, 7. So in short, the longest continuous carbon chain here is 7. We can count from this place, from this CH3, like this, to this place, or we count from this 1, 2, 3, 4, 5, 6, 7. Don't forget that this is C3H7. That is propyl. So we have to count. There's 3 carbon here. That's why it has to be 1, 2, 3, 4, 5, 6, 7. So in short, we know that the parent chain or the parent name is 7. What is the parent name for alkane? That has 7 carbons. That is heptane. Correct. Heptane. So we know that the parent name is going to be heptane, right? So let us keep this somewhere. This is the parent name. Now, the next thing is to identify the substituents. The substituents. We need to identify the substituents. The substituents. When I say substituents, what do I mean? Substituents are just attachments, or let's say atoms that are attached to the continuous or to the longest continuous carbon chain that are not hydrogen. Other atoms that are attached to the longest continuous carbon chain that are not hydrogen. So don't forget, this is our longest continuous carbon chain from this place to this place to this place to this place to this place that are not hydrogen. So what are these substituents? Let's look for things that are not hydrogen. This. You can also get 300 plus in your JAM exam if you are ready to learn. MAX-TUTORS is organizing a JAM tutorial for JAM science students, and it has commenced since November and it is still ongoing right now. This JAM tutorial covers subjects like chemistry, physics, biology, mathematics, and use of English. The tutorial monthly fee is 4,000 naira only. If you are interested in joining this tutorial, do also click the link on my bio and then select the option to join MAX-TUTORS Intensive JAM class, and I will see you in the class. Substituent. Let's look for things that are not hydrogen. This is the substituent, chlorine, because this is not hydrogen. CH3 also is the substituent because it is not hydrogen. Let us continue. Okay, this is a substituent as well. Bromine is a substituent. Why? Because it is not hydrogen. And I think this is our longest continuous carbon chain. And see this also. This is CH3. There's 3 H there. So this is also a substituent. This CH3, you can see this is also a substituent. So in short, we have how many substituents? 1, 2, 3, 4. We have 4 substituents. So let us try to write our substituents out. 4 substituents, we have chlorine. We have chlorine, okay. Let's write chlorine. We also have bromine. Let's write bromine. We also have CH3, which is methyl. Don't forget, we also have another CH3 here. So in short, we have methyl times 2. We have 2 methyl substituents. Now, what is the next step? The next step is to know the direction of naming. Our direction of naming, see, are we going to name in this direction? Are we going to be coming like this, towards this direction, like this? Are we naming towards this direction, or we are naming towards this direction? So we need to choose which one. And how will we choose it? We will choose it by knowing the position of those substituents. Those substituents in either directions. Okay, so let us say if we are going like this. Chlorine is on carbon what? If we are going like this direction. Chlorine is going to be on carbon 2, right? 2. So we write 2, comma. If we are going like this, what is another substituent? Bromine. Bromine is on carbon what? Carbon 4. Carbon 4. So you write 4, right? Also, if we are also, don't forget that methyl, we have 2 methyl. The first methyl, if we are going like this, is on carbon what? Carbon 2. This is the methyl and it is on carbon 2. So 2. And also, second methyl, as you can see here, is attached to this carbon. This second methyl is attached to this carbon. So this carbon is carrying it. Don't forget that this carbon is carbon 4. So we are going to write 4. So in short, all of this, if you add all of this together, you should be getting 442. So that's going to give you 12. 12. So now let us go in the other direction. If we are naming or if we are checking the positions of the substituents towards this direction, what are we going to be having? Chlorine, okay, is this. What is this carbon? Let us number this carbon. This has 3 carbons. That means this is 1, 2, 3. Why this is carbon 4, 5, 6, and 7. If we are naming from this direction, if we are counting from this direction. So our chlorine here is on carbon 6. So you write 6, comma. Our bromine is on carbon what? Carbon 4. 4. And then our other substituents, which is methyl. One methyl is here. This one is on carbon 6, 6. And the other methyl, which is this one, is on carbon what? Don't forget that this is attached to this. Is on carbon 4. Carbon 4. So if you add this together, you should be getting 6 plus 6 is 12. This is 8. You should be getting 20. Right? So don't forget, you are going to follow the shorter route, which is this one. So you are going to follow the shorter route. You are going to be following the shorter method, which is this. So this gave us 12. 12 and 20. 12 is smaller. So you are going to be following this direction. So we are going to be naming in this direction. So another thing is that you need to name in alphabetical orders. You need to name these substituents in alphabetical orders. And after then, you can add this parent chain name, which is heptane. So now let us continue. So chlorine, bromine, and methyl. These are the 4 substituents that we have. The first one is B. B because B comes in the alphabet before C and N. So bromine. Bromine is on carbon what? If we are naming in this direction, like this. Don't forget that we picked this. Bromine is on carbon what? Carbon 4. So we are going to write something like 4 bromo. 4 bromo. Then you write hyphen. Then we are going to move to the next substituent, which is chlorine, because C comes before M in the alphabet. C is on carbon what? On carbon 2. If we are naming in this direction, it is on carbon 2. So we are going to write 2 chloro. And then what is the next substituent? Methyl. Don't forget that we have 2 methyl. 2. And a prefix to show that we have 2 methyl. It is di. We need to make it dimethyl. So that you can know that it's 2 methyl. If it were supposed to be 3 methyl, it is going to be what? Trimethyl. So now, both of our methyl in this direction are on carbon what? This one is on carbon 2. This first methyl is on carbon 2. While the second one is on carbon what? Carbon 4. This is the second methyl. It is attached to carbon 4. So it's going to be 2,4-dimethyl, right? So you're going to have something like 2,4-dimethyl. Don't worry, the bot cannot get to that place, so I'm going to write it here. 2,4-dimethyl. 2,4-dimethyl. Then you are going to put the parent here. You can see that we have already put all of the substances. So you are going to put the parent here. Dimethyl what? Dimethyl heptane. Dimethyl heptane. So this is the IUPAC name of this compound that is written here. If you have any questions, you can send them in the comments, and I'll see you guys in the next one. Peace out.